several more problems. I know you have encountered difficulties on the last few problems, maybe 4, maybe 5, maybe the last 10, I don't know. But today, we have plenty of time. We still have time for chapter 13, plenty of time, and plenty of time for the final review. I can afford to spend 2 or 3 hours just reviewing chapter 12, if I wanted to. All right, so I had this question from one of you saying, what kind of problem is that in terms of triple integral? We have a solid bounded by z equals 3x and z equals x squared. This is a plane. And can anybody tell me what this is? Just out of curiosity, you don't have to know.
It's a parabola.
It would be a parabola if we were in XOC planes in 2D, but in 3D is a... So the parabola is missing the y, and y could be anybody. So take this parabola and shift it along y. It's going to give you a cylindrical surface. It's like something used for drainage, I don't know, water, like a valley.
It's like half a pipe. It's like a pipe cut in half sitting on rock.
Right. So this is what it is, a cylindrical surface. And now you know that z must be between x squared and 3x. How do you know which one is bigger, which one is smaller? Which you should think about it. When you draw like that. Sorry. Do these guys intersect? We are in the xz plane. Do these guys intersect? X squared and equals and 3x intersect where? This would mean they intersect at 0 and at 3. x1 is 0, x2 is 3. So when I were to draw this, I would say that indeed it's a bounded domain. If it were unbounded, it wouldn't ask for the volume because the volume would be infinite. So this thing must be a bounded domain. X cannot go on. This is the infinite part. So we are thinking of just this striped piece of a domain xz, where this piece is between z equals x squared and z equals 3x. This is the origin, and this is 3. So at 3 they meet again. Are you guys with me? At 3 o'clock they meet again. No, I'm just kidding. The x doesn't have to be time. It's a spatial coordinate. Good. And y is looking at you and is going towards you. Well, if it were like that, it's probably not positively oriented, so y should come from you and go into the board and keep going in that direction for the frame to be positively oriented, because positively oriented means x like that, y like this, z like that. So k must be the cross product between I and j. I cross j must be k. If I use the right-hand rule and I go y like that means I change the orientation. So the y, you have to imagine the y coming from you, going perpendicular to the board, and keep going inside the board infinitely much. Now, if we were to play with Play-Doh, and we were on the other side of the, like the Alice in the mirror, okay, we would have the y in the mirror world going between 0 and 2 beside the board. If I were to draw this piece of cake, I start dreaming again, I apologize, but I'm dreaming of very nice bounded pieces of solids that could be made of cheese. This is a perfect example where you have something like a curvilinear shape, and you cut and you slice the cheese, and that's a piece of the Parmesan, whatever it is. Okay? All right. So the y here is going from 0 to 2. It's sort of the altitude. And this is the piece of cake that you were looking, or the cheese, or whatever you're looking at. So what do you put here? You put z between x squared and 3x. You put y between, y is between 0 and 2. And you put Mr. X is the last of the Mohicans. He goes from 0 to 3. Is this guy? So X has the freedom to go from 0 to 3. Y has the freedom to go from flat land to flat land, from between two flat planes, but two horizontal planes. But Mr. Z is married to X. He cannot escape this relationship. So we can only take the z with vertical strips between these two values that depend on x. That's all. Now, why would we have 1? Because by definition, if you remember, the volume was triple integral of 1 dv over any solid bounded domain. Right? Remember that? Okay. So whenever you see a problem like that, you know how to start. You put 1 for the integral, and that's gonna work. Something else that gave you a big headache was the ice cream cone. The ice cream cone problem gave a big headache to most of my students over the past 14 years that I've been teaching Calc 3. It's a beautiful problem. It's one of my favorite problems because it makes me think of food again. And not just any food, but some nice ice cream cone that of artisanal ice cream, not the one you find in a box like Bluebell or Jerry Ben and Jerry. All right. So, how is the ice cream cone problem that Nitish showed it to me, but I forgot the problem number. It was
it's number 20.
Number?
20.
Number 20, thank you. And I want the data. Nitish, don't tell me. I want to test my memory. See how many neurons died since last time. Don't tell me. So I think the sphere was a radius 2, and the cone that we picked for you, we picked it on purpose so that the results that come up for the ice cream cone boundaries will be nice and workable. Because we can propose some data where the ice cream cone will give you really nasty radii. And can I draw? Hopefully. This ice cream cone is based on the waffle cone. I will write the waffle cone because I'm dreaming. So, but the problem is the waffle cone is not a finite surface. It's infinite. It's a double cone. It's the dream of every binger. So it goes to infinity and to negative infinity, and that's not my problem. My problem is to intersect this cone with the sphere and make it finite. So to make it a true waffle cone, I would have to draw, the sphere of what radius? Root 2. I'll try to draw a sphere root 2, but I cannot predict the results. Now, I'm going to only look at this V1 cone. I don't know what the problem wanted, but I'm looking at do they say in what domain? Above the plane?
It just says lies above the cone.
That lies above the cone. But look, if I turn my head like this, depending on my reference frame, I have cervical spondylosis. This is also lying above the cone. So the problem is a little bit silly. Whoever wrote it should have said the sphere lies above the cone for z greater than 0. In the basement, it can continue, that's z. For z less than 0, it can continue upside down. And then between the sphere and the cone, you have another ice cream cone upside down. Okay? But practically what they mean, just do V1 and forget about this one. It's not very nicely phrased. Above, beyond. Are we above Australia? This is stupid, right? Because they may say, oh no, depends where you are. We are above you guys. You think you're better than us because you live closer to the North Pole, but who made the rule that the North Pole is superior? If you look at the universe, who is above, who is beyond? I mean, there is no direction. So they would be very offended. I have a friend who works in Sydney. She is a brilliant geometer. And I bet if I asked her, she would say, who says you guys are above? Because it depends where your head is and how you look and where the planet is the same. So would you say that the people who are walking close to the North Pole have their body upside down? So it really matters of how you look, what's above. So we'll assume that above means, the world above means Z positive, and this is the ice cream cone. Now, how do I find out where to cut the waffle? Because this is the question. I need to know where the boundary of the waffle is. I'm not allowed to eat anything above that. So that's going to be the waffle. And for that, any ideas? How do I get to see what the circle, where the circle will be a circle?
So the two equal to each other?
Intersect. Excellent, Matthew. Thank you. So intersect the two surfaces by setting up a system to solve. Solve the system. And the intersection of the two is Mr. C, which is Mr. Circle. All right, so what do I do? I'm going to say I have to be smart on that one. So if Z squared from here, plug it in, substitute, is the same as x squared plus y squared. That means this is if and only if 2x squared plus y squared, 2 times x squared plus y squared. You have an x squared plus y squared and another x squared plus y squared equals 2. You see how nicely the problem was picked. It was picked so it's going to give you some nice data. Z equals, Z squared equals that. Keep going with if and only if. If you're a math major, you will understand what. X squared plus y squared equals 1. And Z squared must be 1. Well, so we really get two solutions. The one close to the South Pole and the one close to the North Pole, because I'm going to have Z equals plus minus 1. And where's the North Pole? The North Pole will be 0, 0, square root 2. The South Pole will be 0, 0, minus square root 2. And my plane here is cut at which altitude? Z equals 1. And I have another plane here and an imaginary intersection that I'm not going to talk about today. Z equals minus 1. I don't care about the mirror image of the, with respect to the equator of the cone. All right, good. So we know who this guy is. We know that he is, I have the red marker, and a green and a blue. I cannot live without colors. Life is ugly enough, so let's try to make it colorful. X squared plus y squared equals 1. We are happy because that's a nice simple circle of radius 1. Now you have to think in which coordinate you can write this from. And I'm going to beg of you to help me review the material for the final and for the midterm. But maybe on the midterm I'm not going to put this problem, it's too tough for the midterm. So for the final, do expect something like that. We may have, instead of the cone in the book, you have a paraboloid and a sphere intersecting. It's sort of the same thing, but instead of the ice cream cone, you have a valley full of cream, whatever. All right? No, I cannot stop, right? Okay, so if you do the volume, like I told you before, you simply have triple integral.
It asks for surface area.
No, I'll do the volume first. I know you have the surface area. I'm doing the volume because I have plans, and I didn't want to say what plans. You forgot what I said, right? So suppose somebody's asking you for the volume. The volume, how much ice cream you have inside depends on that very much. And I'd like you to remember that the V is practically dx dy dz, right? But to write it in Cartesian coordinates would be a killer. We try to write it in either cylindrical or spherical to make our life easier. Now, if I want to make my life easier, first in cylindrical coordinates, and then in spherical coordinates, could you help me find the limit points? And then we'll do the surface. Just remind me, okay?
So we are finding out the volume of what?
Huh?
We are finding out the volume of what?
The volume of the, okay, the volume occupied by the ice cream. The ice cream is between this plastic cap, that is the sphere. We cover it for hygiene purposes. Okay?
H will be from 0 to square root of 2.
So for cylindrical coordinates, rho and theta are really nice. We don't worry about them yet. But z should be between, okay,
1 square
0
root.
really 0.
This 1 is the square root.
So because between the ice cream lies between the cone, you think waffle cone, what's the equation of the waffle cone? And how do you get to the equation of the waffle cone? The waffle cone meant, oh guys help me, z equals, now you take square root of x squared plus y squared, because the other one would have been here, the imaginary one, z equals minus square root x squared plus y squared. Forget about the world in the basement. So you take z to be square root of, with a plus, x squared plus y squared. In cylindrical coordinates, what does this mean? In cylindrical coordinates,
Z equals R.
z equals r, very good, he's thinking faster. Do you guys understand what he said? X squared plus y squared, if we work with polar coordinates, which is cylindrical coordinates, the same thing, polar coordinates, cylindrical coordinates. X squared plus y squared will be little r squared. Under square root will be r. So z will be between r, and now another harder part. What is the, z equals plus square root of, what was it, guys?
So are we taking the volume of all the ice cream inside the cone as well?
Inside, so between the cone, ice cream lies, here's the ice cream, chips, chocolate chip, between the cone and the sphere.
2 minus R.
The sphere is the bottom function, the lower function is that good?
2 minus R squared.
So I have
Square root of.
square root of 2 minus r squared. I don't like the square root, I hate it. Can I do with it? Can I? Yes, I can. Maybe I can apply a u substitution later. Don't worry about me, I'll make it. I would live better if I didn't have any ugly things like that. So let's see what we have. Theta, your cone is not just sliced cone, it's all the cone. So you have 0 to 2 pi, 1 revolution, complete revolution. How about rho? Rho is limited. Rho is the what lies in plane in terms of radius.
0 to pi.
0 to 1.
Oh,
0 to? How much is from here to here?
1.
How much is from here to here?
2.
Didn't we do it x squared plus y squared equals 1?
Yeah.
So what is this radius from here to
One.
here?
1.
And what's this radius from here to here? 1. So the projection of this ice cream cone, as if you had, the eye of God is here, sun, whatever, you have a shadow on the ground coming from your ice cream cone, and this is the shadow. Your shadow is simply a discovery. Guess what? Good. That's the projection you have. So Mr. Rho is between 0 and 1. For polar coordinates, it's not so ugly actually. 0 to 2 pi, 0 to 1, r to square root of 2 minus r squared. Instead of r, it's all Greek to me, I put rho. You excuse me. And here the big Jacobian. I'm going to erase J, don't write J. Jacobian in general is Jacobian, right? The one that does the transformation between coordinates to other coordinates, the differential map. How about this one? This is simply R. Very good, your old friend. So you have in one word the dz, d theta, dr. Is it hard? It's not easy either. If I were to continue, maybe on the final, okay, I'm talking too much as usual. Maybe on whatever test, you're gonna have this kind of stuff with a formulation saying you do not have to compute it. But if you wanted to compute it, would it be hard? From 0 to 1, from 0 to 2 pi, and say, forget the stinking pi. Magdalena, take the 2 pi out to make your life easier, because the theta is independent from, there is no theta inside. So take the 2 pi out, and then you have integral from 0 to 1, integral from, now, R got out for a walk. He says, I'm going out for a walk. Integral of 1 with respect to z is z. So z is taken between r and root of 2 minus r squared, right? So I would have to write here the 1 on top minus the 1 on the bottom. A little bit of a headache for me. I'm looking at it, I'm getting angry. Now, times the r that went out for a walk. And I have here, so practically the z was solved, and I have the dr. And from 0 to 1. So I took care of who? I took care of the integral with respect to z. This is r here. This was done first, and it gave me that between those two. So I got that. Times the r between 0 and 1 with respect to r, and Mr. 2 pi gets outside. Now, if I split this into two integrals, it's going to be easy, right? Because I go, the first integral will be r times square root 2 minus r squared. How can you do such an integral? With your substitution. For example, your u will be 2 minus r squared, and you keep going. The second integral is a piece of cake, a piece of ice cream, integral of r squared, r cubed over 3 between 0 and 1, 1/3 something. So we can still solve the ice cream cone volume like that. Do I like it? No. Can you suspect why I don't like it? Yeah, oh, by the way, suppose you got to this on the final. How much do you get for, you mess up from now, you mess up the algebra, how much do you get?
50%.
Right? 60, I'm a little bit more generous.
Be optimistic,
So,
guys.
Yeah, 60%. If you tell me u equals, you say, I can do that in my sleep. U equals 2 minus r squared, the u equals minus 2r dr. I can go on. Even if you mess up the algebra, you did most of it. Now, why don't I like it? Because it involves work, and I'm lazy. So, can I find a better way to do it?
Solve the evolution.
Can I use spherical coordinates? And how do I use spherical coordinates? So let me see how I do that. In spherical coordinates, it should be easier. Remember that for us mathematicians taking this course, Calc 3, multivariable calculus, we are not studying geography. So for us, latitude doesn't go between minus 90 and plus 90 degrees, but it goes, measures from the North Pole, because we believe in Santa Claus. Always remember that. So you go all the way from 0 degrees to 180 degrees. So your, in principle, your latitude will go from zero to all the way to pi. But it doesn't, because it gets stuck here. What is the latitude of the ice cream cone? So what is the phi angle for this ice cream cone?
It's 45.
It's 45-degree angle. That is true. So you have a, for anything like that, guys, I'm looking again at this cone. D squared equals x squared plus y squared, right? X is, I just want to talk a little bit about that. So if you have x and y, I don't know how to draw that. This is x, y, I'm sorry. This is x, you have to use your imagination on here. And the hypotenuse will be x squared plus y squared. And this is the z thingy. And then I draw what is in between. This has to be 45 degrees. Can you see what's going on? So a theta has to be between 0 and what? Huh? Oh, yes, you're smarter than me. That was the longitude. Thank you, guys. I'm sorry, I meant to write the latitude. Phi is between 0 and pi over 4. Good. How about the radius? Are you afraid of the radius? No. Why? The radius is your friend. It was not your friend before. Look how ugly it was, but in this case, the radius goes all the way from 0 to a finite value, which is exactly the radius of the sphere. Because you have like rays of light coming from the source origin, and they bounce again against this profile, which is the profile of the sphere, which has radius square root of 2. So life is good for you in this case. Are you guys with me? Should it be easy? Yes, it should be easy to write the integral if you know how to write it. So you have, okay, what do you want to do first? It doesn't matter. You apply Fubini's theorem. You have fixed limits. So you have 0 to 2 pi, 0 to pi over 4, 0 to square root 2. Inside, there must be a Jacobian that you know by heart, and I'm asking you to learn it by heart before the final, if not for now, but at least before the final, but even for now, you should know it by heart.
R squared, sine.
Thank you so much, Matthew. Yes. You don't have much to memorize, but this is one of the things that I told you I did not memorize it. I was a freshman. I was stubborn and silly. So I had to compute what? I had to compute the Jacobian. Imagine what work you have when you're limited in time. You have dx, dr, dx, d theta, dx, d phi. I thought I was about to kill myself. dy, dr, dy, d theta, dy, d phi, and finally dz, dr, dz, d theta, dz, d phi. And I did this. And I thought I was about to just collapse and not finish my exam. I finished my exam, but since I didn't remember that, I had to compute it. It took me 10 minutes to compute the Jacobian, or 15. So this is our squared sine phi. If you have nothing better to do, you can do that. Do you remember what the spherical coordinates were? out of curiosity? Who remembers that? There are some pre-med majors here who probably remember that. So when you have a phi here, you have r sine or cosine? Cosine. R cosine phi. And then r sine phi for both times what? The first one comes with theta like that. It's going to be cosine theta and sine theta. Well, imagine me taking these functions and differentiating them, partial derivatives. And after I differentiated them, compute the 3×3 determinant. It's a killer, no matter how good you are at computing. So don't do that. Just memorize it. Don't do like I did. And then you have d what? dr,
dr, d theta,
d phi, d theta. Now, what is the volume of the ice cream? I'm gonna erase. It shouldn't be hard. This is the type of problem where you have a product of functions of separate variables, and you can separate as a product of three independent integrals as a consequence of Fubini's theorem. So you have integral from, integral from, integral from. Who's your friend? Who you like most?
Theta.
You like theta the most?
Yeah.
Because it comes from Santa Claus? Okay, the theta. No, the theta doesn't. This is the easiest actually, 0 to 2 pi.
It's 1.
So is 1. So that's why you like him, because he's the easiest to deal with. How about phi? Sine phi, d phi. Well, this is, I agree with you, is not so easy, but it's gonna be a piece of cake anyway. How about this one? 0 to root 2 r squared dr. Is this guy hard to do? Nah. R cubed over 3 will give me root 2 cubed over 3. How much is that, by the way? 2 root 2 over 3. Well, bless your heart, that's not so hard. This is not a problem. How about that? You have, what do you have? What is the integral of sine? Negative cosine. So you have minus cosine phi between pi over 4 up and 0 down. Good luck to you. Well, first guy. Good. Minus root 2 over 2. Minus second guy. Minus minus 1. Good. Don't fall into the trap. Pay attention to the signs. Don't mess up, because that's where you can hurt your grade, messing up with minus signs. Good. So this is 1 plus 1. 1 minus root 2 over 2. And finally, let's see what that is. The whole thing will be, can we write it nicely? What's 2 times 2? 4. 4 root 2 over 3 pi, the first and the last. 4 root 2 pi over 3 times this nasty guy 1 minus root 2 over 2. I don't like it. Let's make it look better. Let's make it look better. Well, okay, you can give me this answer. Of course you get 100%. But am I happy with it? If you were to publish this in a journal, how would you simplify? Oh my God, this is dry. Okay, so what do you have? 1 is 2 over 2. 2 minus root 2. Root 2 pi. 4 and 2 simplify. Are you guys with me? There is a 2 down and there is a 4 up, so I'm going to have a 2, another 2, all over 3. So I have 2 root 2 pi times 2 minus root 2. Do you like it like that? I don't. So what do you do next?
4 minus 2 root 2 times root 2.
I can even pull the root 2 inside. So I go 4 root 2 minus what? Minus 4, because this times 2 is 2, times 2 is 4, pi over 3. Do you like it? Still I don't, because I'm stubborn. 4 root 2 minus 1 over 3 is the most beautiful form. So I'll try to brush it up and put it in the most elegant form. It doesn't matter. If you were to give me a correct answer in any form, it will be okay. Yes, sir.
If it was slightly different, how would we find phi for the limits in the second?
If you have a what?
Like, how would we find phi if it wasn't obvious? Like, if it wasn't x squared, z squared.
If it wasn't 45-degree angle, you are doomed. It's not so bad. I mean, you need a calculator. Assume that I would have given you the sphere of radius 7 or square root of 7 intersecting with the scope. Then to compute that phi, you would have needed to intersect the two surfaces and then compute it maybe with tangent inverse. Compute phi, the limit with tangent inverse, and you have tangent inverse of a number. Well, you cannot put tangent inverse of a number everywhere. It's not nice. So what you would do is, in the end, you would do it with the calculator, come up with a nice truncated result with 5 decimals or 10 decimals, whatever the calculator will give. Okay? All right. So, or you do it with MATLAB. You can do it with scientific software for sure. Let's do what I owe. Ryan, you said this was a what?
Number 20, but it's the 20 is for the surface area.
Okay, so it's, read it to me again, or Nitish. What does it say? I'm coming to you. It says, find the surface area of the part of the sphere that lies, well, you have 64.
I have it.
64. But this is all because of Nitish. But yours is not bad either, right? Because
It's a sphere of radius.
yeah, so it's all in all, you shouldn't have bad results. And guess what? If you do, you use your calculator and to find out the upper limit of the angle, whatever, for the volume. Okay. So now you say, oh my God, this is ugly. I agree with you, it's not nice. You have square root of 2 minus x squared minus y squared. And when you compute the surface area of the cap means spherical cap. A little hat that looks like, okay, that's why it's called cap. Double integral over the disk D of
The
square root of 1 plus f sub x squared plus f sub y squared dx dy. Is that the only way you can do this? No. You can actually do it with parametrization for a sphere, and you have the area element over here. So that probably might be easier.
Can't you also do it in polar?
Yeah, you can also do it in polar. But what if you would attempt, okay, let's see how hard is life. How hard would it be to do it like this? Let's first of all, let's take everything that's under the square root and write it down. 1 plus. Now, computing this prime with respect to x, and you say, oh my God, that's hard. No, it's not. If you were good in Calc 1, and most of you were, and had a professor who gave you enough practice, what would you have done? Chain rule, right? On the bottom, you have this nasty guy twice the square root, but on the top, you have minus 2x. So when you simplify, your life becomes easier. And you go square. Are you guys with me? Have I lost you yet? No. Okay, good. And then the same thing in y. Minus 2y over 2 square root 2 minus x squared minus y squared squared. Some things, life is good. Some things cancel out. So let's be patient and see what we have. First of all, 1 is not going to give you trouble because let's write 1 as this over itself. Plus, minus squared is plus, thank God. X squared over 2 minus x squared minus y squared plus y squared over 2 minus x squared minus y squared. And these guys go for a walk. Minus x squared. You take the purple. Minus y squared plus y squared. They disappear together in the dark. So you have 2 over 2 minus x squared minus y squared. All right? Okay, let's try to do that. So you have, I'm gonna, guys, I have to erase. I will erase. So this, what you see here, some people call ds, and is the element of area on a surface. Element of area on a surface is like the area of an infinitesimally small surface patch, sort of curvilinear square. All right, so area of the cup will be, now you say, well, over the D, let me think. D represents those xy's with the property that, you tell me what, you forgot? No, you didn't forget. X squared plus y squared was between what and what? 0 and 1, because that was our, the projected domain on the shadow on the ground. Okay, that was this unit. And does it look ugly? I have to put it on the square root. Don't be afraid of it because it's not much uglier than you thought. And let's try to solve this together. What is your luck that this is a symmetric polynomial in x and y, x squared plus y squared, that you can rewrite as r squared in polar coordinates? And who asked? Ryan asked. Can I do polar coordinates? That's exactly what you're going to do. You didn't know unless your intuition is strong. Yes. Alex, tell me, no?
I was going to ask if you have done that by taking the arc length and then multiplying that by 2 pi r. Taking the arc length.
Yeah, you can do that. Yeah, well, there is a way to do that. So practically, he's asking, I don't know if you guys remember, in Calc 2, forget about the Calc, you had the surface of revolution, right? And if you knew the length of an arc, you would be able to revolve that arc. It's like this is the cap. And you take one of the meridians of the hat and revolve it. Can we do with a different formula like the washer, like you did the washer and dryer method, whatever. It always amuses me. Yes, you could have done that from Calc 2, computing the area of the cap with as a surface of revolution. Chapter, come on, I'm a co-author of this book. Chapter 7, no. Chapter, what chapter is that? Chapter 6? No, the washer and dryer?
Yes, chapter 6.
Chapter 6,
I
right?
guess I used a different textbook.
Okay, but now we are in Calc 3 and we don't want to remember Calc 2 because it was a nightmare. Several of you told me that this is easier. These things are generally easier than Calc 2 because Calc 2 was headache, and what seemed to be giving you most of the headache was that it was a salad of different ingredients that seemed to be unrelated, which I agree. You had arc length, washer, slices, then trig substitution, then partial fractions, all sorts of things, series and sequences. And they are little things that don't quite follow one from another. They are a little bit unrelated. Okay, how do you do that? You have to help me because that was kind of the idea that now you can help me, right? Square root of
2 minus r.
2 minus r squared times r dr d theta.
And do we like it? No, but we have to continue.
Use 2 minus r squared.
0 to 1 is 0 to 2 pi. I can get rid of the 2 pi and put it here and then say, okay, I should be as good as picking out square root of 2 from here. He goes out for a walk. And then I have integral 1 over this long line of fraction. Root u.
And there will be 2r, so the r will cancel out.
So RdR, if u is 2 minus r squared, du is minus, I have to pay attention so I don't mess up with the signs, right? So RdR is a block, and this block is simply minus du over 2. So I write it here, minus 1/2 du over 2. And you don't be nervous about this minus, because it's not going to give me a minus result, a negative result. If it did, that means that I was drunk when I did it, because I would get the area of the cap is a negative number, which is impossible. But it's going to happen when I change the limits. Yes, sir.
Where did that minus 1 come from?
From this one.
So,
Yeah, they have another du over.
Oh, I put too many. So this guy is this guy, which is this guy, minus du over 2. Thank you, I put too many.
So the r, if you put between 1.
Now, do you want me to go ahead and cancel this out? Right? Okay, so I have square root 2 pi. I did not put the endpoints. You have to help me put the endpoints.
So there will be 2.
From 2 down to 1, which is crazy, right? Because 2 is bigger than 1. That's exactly where the next minus is going to come from. So integral from 2 to 1 is minus integral from 1 to 2. So I shouldn't be worried because I already had the minus out. With the minus that going to come out, I'm going to have a positive area. Good. So square root 2 pi. What is, well, somebody was smarter than me and said, Magdalena, I think, Alex, was it you? You said, why don't you take advantage of the fact that you already have 1 over 2 square root u and integrate, and that is going to be square root u. Do you understand? Who said that? I heard a voice. It was not in my head, I promise you. I heard a voice who told me, if you were smart, you would understand, pull out the minus. You'll understand that this exactly, but exactly, is the derivative of square root u. And I would do faster than you because you have just square root u between 1 and 2. Some people are too smart. I didn't think of that. Now I'm thinking about it. You're right. Why cancel out the 2 when you could have done that? So you have a minus out.
There still needs to be a 2, right, on the outside?
Yes, sir. I have to put 2, gather it together, minus 2 pi, that's the collective thing, square root u between 1 and 2. Now,
Root 2 minus 1.
Do I like this? No, but you tell me what it is in the bracket.
Root 2 minus 1.
How much is 1 minus square root of 2? 1 minus square root of 2 is a negative number, but with the minus outside, I'm gonna fix it. And I'm gonna get something really ugly.
4 pi minus 2 pi squared.
You're right, but yeah. So when I multiply inside this by that, I get 4, right, guys? I get a 4. This guy and this guy minus plus 2 root 2 times 2 is a 4. And then minus, to make it look better, 2 root 2, and the pi out. Minus 2 root 2 and the pi out. Now, I don't care where you stop. I swear that if you stop here, you still get 100%. Because what I care about is not to see a nice simplified result so much. I will go over your work. But to see that you understood how you solve this kind of problem. Okay? It's not the sign of intelligence being able to simplify answers very much. Okay? But the method in itself, why and how and what the steps are, that shows knowledge and intelligence. Yes? Have I made the mess up? No, I don't think so.
No. Does the order matter of the dr, d theta, or dx, dy? Does it matter which order you put those in?
In this case, no.
Or over here?
In this case, no, again. But if you were to swap them, then you have to swap the values as well.
And it's the same.
Why is that? That's a very good question, but he's right. But why is that? It doesn't matter. Why? In general, it matters. Okay? They have to be from a given number to a given number. It's not like reversing. When you reverse the order of integrals, is usually harder because you have to draw the vertical strips and you have it between two functions. And then from vertical strips you go on horizontal strips and you have other two functions. So you always have to think how to change the functions. Here you don't have to think at all. You have a function that depends on r only. There is no theta in the picture. Plus these two are fixed numbers. You can reverse the order of integration in your sleep. Okay, you get the same thing. All you have to do is swap these two guys and swap, the 0 is the same. Swap these two guys and then you're done. Yes, sir.
How did you take the 2 pi out, that integral?
What did I do? How did I take this out?
No, the 2
This?
pi.
Oh, the 2 pi.
Yeah.
Okay, let me show you a theorem here, because we've discussed about this before. When you have integral from a to b of integral from c to d of a function of r only and a function of theta only.
I got it. So it would just be.
What do? You go, there is a theorem that says that thanks to Fubini's theorem and the fact that the variables are separated in this product, this is the product between integral from a to b g of theta d theta and integral from c to d f of r dr. They have nothing to do with one another, the product in the end. So what do? You say this is integral of 1 from 0 to 2 pi d theta times the ugly guy. So this is 2 pi.
Okay.
And you're done. When theta doesn't appear inside, it's a blessing. But even if, guys, I have a question. What if theta appeared inside and he was, theta doesn't appear inside by himself. He appears inside a trig function. So assume you had cosine theta here, times r. You would have pulled cosine theta out, whatever, and integrate cosine theta, and that would have been easy. And if it were a problem like that, you would have gotten 0. Because integral of cosine to theta would be sine of theta. And then theta between 0 and 2 pi, sine of theta between 0 and 2 pi would give you 0. It happened to me many times in the exams. It was a blessing. I was 19 and I was so happy. Professors wanted to see only the answer. Because In Romania, it's different. You come, take a written exam, and the professor has 5 hours to grade it. The same day, 2 hours later, you enter oral examination. You pick up a ticket. On the ticket, you see 3 things to solve, 4 things to solve. You go take a seat, and while the professor and the assistant grade the exam, you actually think of your oral exam. When you come and present your results on the board, they tell you, you messed up, you got a 60% on this thinking exam, right? This is how it goes. Or, on the contrary, hey, listen, you got 95% on the written part, okay? I don't want to see what you have there. It really looks good. I don't want to insist. It's clear to me that you know what you're doing. So it's a different kind of examination. I hear that Princeton does that. I wouldn't want oral exams here. I don't think people are ready for them yet. But in Princeton, they do all the same. Take a hat, take a vase, put tickets in it. Nitish comes and closes his eyes and picks a ticket and says, oh my God, I got proof of Bini's theorem and do these 3 triple integrals. This is the type of oral exam that you will have. But if you know them, because you studied, you're not ashamed or you're not afraid to present them. But you have to present them and you have a limited time. Because there are other 30 students in the classroom, you only have 5 minutes. And I only pick, I want to see your work on all of them. And Nitish, you have to present only this problem on the board. And you have 5 minutes to present. If you are really embarrassed and you don't want to speak in public, then you have a problem. I've had many peers, and in other countries, I heard that in England they have the same system. There are people who are too shy to show the results or too shy to talk. And then they start stuttering. But they have to do it. There is no excuse. They don't care if you have problems with your speech or what. And so I asked the people I knew when I went to London, and they said, most people who stutter that was so unfair, I thought. Most people who stutter in our oral exams are people who spent too much time in the pub the previous day. And pubs were everywhere, and I saw lots of students in the pubs. I went to University of Durham. This is where Harry Potter was filmed, by the way. And I saw the castle, which is a student dorm. You pay something like £500, which would be like, how much, guys? About $800, $1,000. Maybe less, because now I think it's $750, something like $800. It used to be that a pound was all double the dollar,
Yeah, it
Oh,
was
not
like, it was
anymore.
like two, it was like
It's,
two
the
cents
euro
when I
is
was
weak,
there.
and the pound is weak. So you could stay in that dorm for $800 per month and eat at the same table where they ate in the movie. It was really nice. But the University of Durham is isolated. The castle, the cathedral, everything is very old, from the 11th century, 12th century. But if you go into the city, it's full of pubs. Who is in the pubs? The calculus students. This is where they do their homework. And it amazes me how they don't get drunk. I'm not used to alcohol because I don't drink. Well, they are used to. So they very nicely can do their homework beautifully next to a big draft of Guinness like that, and still make sense. Well, when they write the solution, they don't miss a minus sign. They are amazing.
Say they would be drinking and driving.
All right, is this hard? If you are interested, you could ask about study abroad. We don't have a big business with England, but you could go to Seville. There are some programs in the summer where one of our professors teaches some differential equations. I told you about him. He teaches differential equations this summer, 3350 in Seville. So I think you could still add in the next 2 days. Some of you did, some of you didn't. All right? Any questions about other problems? I have to apologize on I played the game without telling you the truth. Nitish knows, he came to me last time and said, you never showed us this notation. So what if one gives you x of u v equals 2x minus y, y of u v equals 3x plus y. What the heck is that? He didn't say heck because he's a gentleman, but he said,
Sometimes.
what, sometimes, but he said, this is the notation used in web work, and the book is actually not emphasizing it, which is true. The book is emphasizing the Jacobian in section 12.8 only, which is not covered, is not part of the material. But the definition, you should at least know it. So what will be the definition of this animal? You simply have to take the partial derivative of x with respect to u, the partial derivative of x with respect to v, the partial derivative of y with respect to u, the partial derivative of y with respect to v. And that's exactly what it is in determinant. Not the matrix, but the determinant. So, do I bother write it down? If I wanted to write down what it is, of course I would write it down like that, explicitly. I don't want to spend all my time doing that because it's such an easy problem. What do you have to do? Just compute for such a simple transformation in plane. Actually, if you took linear algebra, again, who is enrolled in linear algebra? Only 1, 2, 3? I thought you were only 2. Okay, in linear algebra, guys, you wrote this differently. You wrote it like this, x and y equals matrix multiplication. You have 2 minus 1, 3, 1. By the way, it's obvious determinant of this matrix is different from 0. This is a linear map that you are applying to the vector xy. And in your algebra book, you're using, what are you using? Larson, am I right? Larson's book from Cengate. It's a good book. So you have A of the vector x, this is a vector. A of the vector x is the vector v, all this vector v. It's the linear map. When you will all get to see linear algebra, you'll like it more than Calc 3 because it's more fun. So how do you do the matrix multiplication? It's very easy. This times that minus this times this is this. This times that plus this times this is that. So can computers do that? Yes, computers can if you have the right program. And this is the first program I learned in C++. No, it was the second program. How to write a little program for a multiplication of two matrices. The first program I had to learn in C++ was build an ATM machine. I hated that because every time I went under zero with my balance, I would have you went under zero, so I'd have to prepare for all the possible cases and say, you don't have enough money, whatever. So that was the first program we wrote. Okay, so what do we have? 2 minus 1, 3, and 1. What is the Jacobian in this case? It's 2 plus 3, 5. Different from 0. Right? You have 1 or 2 problems like that. 3 problems like I was really mean. I apologize, but you still have time to do those problems in case you didn't do it.
So we just take the determinant of it?
And you take the determinant of the matrix, exactly that matrix, and that's your Jacobian J.
What numbers are those?
I don't remember, Nitish, tell me. Roberto.
What if it's the U and the V is at the top and X and the Y at the bottom? You just put anything.
So the determinant will be the same. This is a very good question. Are you guys with me? So he said, what if you have your first equations, they would be this one, right? And you have your equations written like that, right? Okay, so when you look at this, you go dyx, but it depends how you, in which order you do that. I wrote uv. Sorry, u and v, but you understood what I meant, u and v, right? U and v.
Can you do number 32, which is a really hard one?
I will, just a second. So dyx with respect to uv. What would happen? I would flip the x and y. What would happen? I get 3, 1 is still the same function, 2 and minus 1. Why do I get minus 5? So imagine, guys, what happens when you have x and y. If you rotate, you don't change the sign of your matrix of rotation. Matrix of rotation will always have determinant 1, for example. But if you flip it, if you swap x and y, you are actually changing the sign of the Jacobian, the sign of the matrix. You are changing your orientation. Okay, that would be a hypothetical situation, but you are changing your orientation. Do you have number? You said, right?
32.
Is it hard? Why is it hard?
Or it's
Yeah. Okay, let me do it. It's hard enough. It's computation. Were you able to do it? No.
what?
Not yet, right? So this is x naught. Okay. So you can write this also differently. X sub u, x sub v, y sub u, y sub v. Who could tell me? Well, there are ways to do it in a simpler way, but I don't want to tell you yet what that way is, and I'll show you next time. What is x sub u? It shouldn't be so hard, right? Because it's quotient rule. You have 4 times u squared plus v squared minus, you write this with respect to u times that, minus 2u, the derivative of this times 4u, divided by the square of that. Did I go too fast? So what you have is 4u squared minus 8u squared equals minus 4u squared plus 4v squared divided by that. And that's what you have. V squared, squared, sorry. X sub v. Well, that should be easier. Why is it easier? The first guy prime minus second unprime plus minus the second guy prime, the second guy, so first prime, second unprime, minus second prime with respect to v times the first prime, the first unprime. Divided by u squared plus v squared squared, which is minus 8uv over that. Is this the one of those that you said you couldn't do it yet? Or you? Well, you did this one? You got the right answer? Good. x sub y sub v, y sub, let me do the y sub u first. Y sub u is a cake. I have a minus 0 times the second one, minus this primed with respect to u times 6b over the square of that. And finally, y sub v equals minus derivative of the top with respect to v, 6 times u squared plus v squared, minus derivative of the bottom with respect to v times 6v divided by the whole shebang. Now, is it simplified? No, I will simplify in a second. You get minus 12uv. I'm not going to finish it, but we are almost done, okay? Why are we almost done? This is very easy. I mean, not very easy, but doable. How about this guy? What do you get? A 6u squared, a 6v squared, a minus 12v squared. It's not that bad. So you have 6u squared minus 6v squared over u squared plus v squared squared.
You also have the negative sign.
What did I do?
Like you didn't, yeah, you need to multiply by negative for y you and y.
And the minus in front. I didn't copy it. Let me make room for it. Thank you, Nitish.
It's also the 12.
12. That's right.
It's 12 UV because there's a negative in front of it. This is minus times minus 2u.
Here,
No, y sub u.
The third one.
minus minus plus, that's good. Thanks for observing things. Anything else that's fishy? Minus minus plus, minus. Okay, that's gonna change the signs. When I move on to this one, remind me to change the signs, okay? So what is the Jacobian? I'm too lazy to write this thing. I'm gonna have, so x sub u. 4 times v squared minus u squared. Let me kick out the, okay, over, let's call it over a. This is called a, right? This is called a. I'll show you what happens. Maybe you don't know yet what happens, but I'll show you what happens. And then the next one is going to be x sub v, minus 8 uv over a, y sub u, 12 uv over a, and plus, with your help, this was plus v squared minus, so 6 times v squared minus u squared over a. Okay, okay? Okay, let me erase this. Now, do you guys know what happens when you have something like that? A determinant has one line multiplied or a column multiplied by a number. If you have alpha A, alpha B, alpha, and C and D, determinant of that is alpha out, A, B, C, D. They assume you know this from high school, but I know very well that many of you don't. How do you prove that? Very easily. This times that would be an alpha out minus this, an alpha out determinant. It's very easy to prove. So when you have one line or one column multiplied by an alpha, that alpha gets out. But if you have two lines multiplied by an alpha, or two rows, alpha squared, excellent. So who gets out? 1 over a squared, which means this guy to the fourth. Sorry about this long. I don't like this problem. Just this computational, you have to go through this. Okay. So, I would simplify it as much as I could. Let's see. A 4 I missed. I ate it. So you have 24 times b squared minus u squared plus, what's 12 times 8? 96, am I right? Yeah. U squared b squared divided by all this ugly guy, which I hate, to the 4th. Fortunately, everybody is a multiple of 24. So we can pull the 24 out and get it out of his life, our life, because it drives us crazy. And then you have b to the 4 plus u to the 4 minus twice. Was that the binomial formula? Minus 2 u squared b squared. What was left when I pulled this out? I pulled 24 out, and 196 is what times 24? 4. So I had a 4 left. So I will put it down. 4 u squared b squared over there. It looks symmetric, but that's okay. It's not so bad. So can you write this better? Look at it. What does it look like? Do you like it? There is a 3. The 4 and the 2, 4 minus 2 is a plus 2. Just like you did those tricky things in high school. That will be, again, the binomial formula, u squared plus v squared squared. Are you guys with me? Because minus 2 plus 4 is plus 2. This is exactly the same thing as that. Over u squared plus v squared to the 4th. If you have problems computing that, send me some emails from WebWork, because I'm going to help you these days, okay? 24 divided by what? Who tells me? U squared plus v squared squared. Oh my God. All right. So I'm not going to think lesser of you if you don't do this thing. Therefore, if you get in trouble, click from the expression, from the whatever you got, and say, this horrible problem gives me a headache, help. And I'm going to help you with the symbolic computation. That is just algebra. That's not going to teach you anything more about Calc 3. That's why I'm going to help you. So I'll help you with the answers on those. Just send me emails. I'm planning on still reviewing, even on Tuesday. I don't want to teach anything new because I'm tired. No, I'm just kidding. I don't want to teach anything new on Tuesday because I want you to be very well prepared for the midterm. So I'll do a general review again, and I'll go over some homework-like problems, but mostly over exam-like problems. So I want everybody to succeed, to get very high scores, okay, in the midterm. But we need to practice. It's like you did before your SATs or whatever, right? It's not that much. I mean, what happens if you don't do great on the midterm? The midterm is a portion of, not a huge portion, but it's a portion of the final. But what I'm trying to do by reviewing so much for the midterm is also trying to help you for the final, because on the final, half of the problems will be just like the ones on the midterm, emphasizing the same type of concepts. So it's good practice for the final as well. All right, good luck. I'll see you Tuesday. Let me know by email how it goes with the problems.